All right, what follows is a discussion of application of linear systems. When we deal with linear systems in function form, the algebra is actually pretty simple, but trying to apply the algebra in real life can be, well, you have to pay attention to detail, so it can be challenging for some. The important thing that we do here is not focus on the equation or the graph shown itself, but to read the paragraph, because the graph and the paragraph are somewhat misleading. What we learn is that the African American mortality rate and the white mortality rate were both dropping over time from 1960 to 2000. But in 1960, there was literally twice as many African American mortalities, infant mortalities, than there were white infant mortalities. So not only have both of these mortality rates been decreasing over time, but the gap between them is getting closer and closer and closer. So this we could see as a positive sign. That is to say that the inequality gap is getting smaller over time. But when we look at the actual question, they're giving us the mortality rates for 1980 to 2000. So they're just talking about this portion of the graph. So what I need to do is I need to understand the 1980 to 2000 portion of these functions and to produce a graph that's going to show me more of what I need to be able to answer these questions. So I start with understanding the African American mortality equation, which translates directly to the mortality rate. It starts at 22 per thousand in 1980 and decreases by about 4.1 deaths every 10 years. What it did there was, I said instead of 0.41 deaths per year decrease, I made it into something that makes more sense to me. That is, if there's 0.41 deaths per year decrease, that's 4.1 deaths every 10 years, and that's what produces this table of values. You see, every 10 years I go into the future from 1980, I can drop 4.1 deaths out of 1,000. So that gives me these data. Using similar reasoning, I can find the white mortality rate equation as starting at 10 for every 1,000 births in 1980 and decreasing by 1.8 deaths per 1,000 for every 10 years. And so there we see, again, some data. Now, the nice thing is, I'm going to make a graph. I don't even have to think about rise over run or move up and over or any of that stuff. I've done all that thinking here in context, and it made a lot more sense to me. Now I have three data for three data for the first set and three data for the second set that I can use to make my graphs. So I used a ruler here to get out my scale, and I counted by tens for years, and I got the mortality rates all the way up to 25. So that I could see what I need to see on my graph. Now, my graph, when I extrapolated, didn't really show an intersection, and I don't think it's even really that accurate because these aren't very trustworthy locations of my points. I'm doing this digitally or electronically, so my graph isn't very reliable. But even with an unreliable graph, I can see clearly that after 2020, there's still going to be a gap between the African American and white infant mortality rates. However, in some time after, it appears as though the intersection is going to be, so we can anticipate that our x value is going to be bigger than 40, probably closer to 50 when I do the algebra. So everything that you see here is the kind of work that's done to demonstrate that you understand the nature of the question and you know what we're getting at, and you're representing it in numerical form and graphical form. And now, since it's an algebra class, let's do the algebraic form as well. My question is, when will the mortality for white Americans be the same as for African Americans? And so essentially I'm going to set these M mortality rates equations equal to each other, like that, which is a simple algebra equation. It's going to involve a little bit of calculations that are a little bit beyond, high school math. We're going to use a calculator, in other words, and I get 52 years after 1980. Now, that's a ridiculous answer. We should answer in context as the year 2032, but this is where I start so I can finish answering the question. I needed to know what the infant mortality rate is for both groups at that time, so I put this time into both of my equations just to verify that the mortality rate is the same at about 0.61 deaths per every 1,000 individuals born. The 0.61 is really encouraging because that's 0.61 out of every 1,000 births. If we had 10,000 people born in a year, we can anticipate that only 6 of them are going to experience complications. That's a very encouraging sign. But of course, that is several years into our future yet, so we have no guarantee that this rate is going to be achieved. But it's a very optimistic outlook. Now that I have the solution, I express the solution as an ordered pair, but because it's contextual, I'm also going to say that assuming the rate remains the same, which we don't really believe, but assuming the rate remains constant, the African American and white infant mortality rates should be the same around 2032, with about 0.61 deaths per thousand births. So that's the complete picture. When I'm doing my homework, though, I would like to make sure, since there's no back of the textbook here, I should make sure that I'm doing this work correctly. So what I'll do is I'll go to Desmos, and I'll verify that when I put both equations that were given to me into the Desmos, find the point of intersection, bam, I have the same numbers that I got with my algebra. So that's the process. Thanks for watching.